Alrighty, well hello everyone and welcome to another lovely webinar from the MEP team at CTC. My name is Don Rasmussen, MEP Applications Engineer here with CTC, and today we're going to do the Parts 2 webinar for ducting soup to nuts. As always guys, if you've got questions, feel free to type them into your browser for the webinar, and we'll get to them where applicable throughout the webinar. If not, we'll try to save a lot of them for the end. So let's get started here. A little bit of what we're going to talk about today. John did a great job on ducting soup to nuts part 1, going over a lot of the settings for ducts, as well as some of the outer routing capabilities that Revit has. For this purposes of this webinar, we're going to get into a lot of visibility control, view filters, view templates, and then we're going to take a look at spaces. We're going to look at spaces for how they're more than a room. We got a question actually coming in, but there's no audio assigned here. Let's see if I can pause and start this again here, guys.
The broadcast is now starting. All attendees are in listen-only mode.
Audio there. All right. You guys will have to respond in the questions if you can hear me now. I can't really see you, so I'll go ahead and start over since there was no audio the first time. All right. So hello everybody and welcome to Revit MEP Ducting Soup to Nuts Part 2. This is Don Rasmussen, the MEP Applications Engineer here at CTC, and this is going to be a continuing webinar on the Ducting Soup to Nuts Part 1 that John Atkinson did for us. I believe it was last month, and he touched a lot on the topics of ducting setup as well as some of the outer routing options that exist inside of Revit for ducting. Today we're going to focus on some different stuff, obviously, expand a little bit on what John talked about. Today we're going to talk mainly about visibility control, how to use filters and templates to control the visibility of ductwork. If you attended the piping duct soup to nuts webinars, there wasn't nearly, or there was a lot of visibility control in those webinars. With ducting, it's not nearly as crucial as it is with piping, but we will still touch on it here with duct because there are some valuable things to pull from that, as well as spaces. I train a lot of people across the country on Revit MEP, and I'm always amazed to see how people have misused spaces and don't quite understand the capabilities of what spaces can do for you inside of Revit. So we're going to touch a little bit on that and some of the awesome power that spaces have and things that you can do with those. As well as analytics, we're going to look at some color legends here and how we can create some views that go ahead and help us in our duct design so we can get done faster and just kind of be more efficient with our overall design process. And so, as always, guys, any questions that you have, go ahead and type them into the browser, and I will see them on my end, and we will answer those where appropriate throughout the webinar. If I don't have an opportunity to answer those right in line with the topic at the time, we'll go ahead and save a lot of those for the end. So let's go ahead and get started. I'll fire up Revit here. And what we see first of all is my overall 3D view. We're going to talk a little bit about views, templates, and view filters. As you can see over here, I don't have any view template applied at the moment, and I don't have, obviously if I don't have a view template applied, I don't have a filter inside of there. Our view filters obviously are located underneath our view tab. Here's our filters right here. If I go into my view filters, you can see that I have lots of different view filters already established, and I have lots of established for duct. I basically have these broken out per system. You can see duct system here, and then I also have duct size busted out. And so I can go ahead and come in here and just click on any one of these, click edit, brings you into your filter dialog box, and allows you to modify any filter that exists or create any new ones that you would like to see. Obviously here you have a delete option, a duplicate option, and a rename option. Excuse me, a new option, a duplicate option, a rename option, and a delete option. Obviously underneath categories, if we scroll up and down this list, it shows you this is where you get to choose to what you want that filter to be applied to, be it duct or pipe or anything else, mechanical equipment for that matter. But you would make your selections here, and then obviously set your rules here underneath your filter rules. You have a 3-tier filter rule system, so you can really drill down to get to a lot of those views, create the views that you want to see. But if I have my filters all established like I do here, those filters can also be applied to view templates. And so I'll come in here, I'll click where it says none on the view template, and I'll start looking at what I have for view templates. Well, right now I have just an HVAC riser for duct. So let's go ahead and look at that view template for a minute. More importantly, the filters that are applied in that view template. So if I open up this view template here, you'll see that I have just a simple system class view template, and it's a not system class view template. If it's not error, the visibility for that is not checked, so this would not be visible. So therefore, this filter really isn't applied to this view. Not using it at this view to control things, because what I'm doing with this particular view template can be controlled mainly categorically here. So wherever categories don't quite cut it for us, which was a big theme in the piping soup to nuts webinar, filters really fill in the gaps. Now I have these other filters created in here, not specifically for this view obviously, but because I may want them in other views. There can be a myriad of reasons why I may want to divide that up into a bunch of different views, mainly for exports. I like to export out of Revit with my different systems for the duct, simply because when I put them together in Navisworks, I can put my clash detections together a little bit faster than if I had just, say, for example, exported the entire MEP model and tried to set up clashes. So I'll go ahead right now and apply this duct riser view template to this 3D view. Click OK. And you see the power of view templates goes ahead and just shuts everything off and only shows my ductwork. Now obviously I can have this, have the additional filters that I want to apply here that would change a lot of this. So I can go ahead and go into that view template. I can go into duct riser here and let me go into the filters. I'm going to add a filter. I want to go ahead and add my, let's go ahead and add supply air. Okay. We're going to make sure that that's visible. We'll go ahead and turn that visibility off. Click OK and OK. You see how it goes and shuts everything off that was on my supply air. Now obviously it's not applied to my terminals. My terminals are still on, so it just shut off my ductwork. And again, that's the power of filters. And those filters can be set up in lots of different ways. If we actually take a look at that particular filter, oh, excuse me, let's go in this way here. That was the supply air filter. We'll see that that one's looking at the system abbreviation for the supply air. That system abbreviation is pulled from your systems, your duct systems, so it's very similar to pipe. So if we scroll down here underneath the families and we expand our duct systems and we look at supply air, we right click on that, say type properties. Here is our system abbreviation. Now again, it's very important to make sure that your system abbreviation here matches your filter. If we adjust the filter and we undo that system abbreviation in the filter will cease to work, and vice versa. If I come in here and I change this abbreviation to take out the slash, say for example, between the S and the A, that's going to break the filter. So it's really important that your filters and your system abbreviations are in concert with each other if that's what you're going to use to create the filter. Cancel out of here. And so that does a little bit about visibility control and filtering inside of Revit MEP. Obviously, this is something I would encourage you to kind of play with, set some filters that would help you be better designers and bring you more in line with the company standard. We're all trying to be more efficient, obviously, when we're using Revit. Filters help us to accomplish that. So, all right, getting away from filters for a minute, and I want to talk about spaces. Spaces are an integral part of what we do in Revit MEP. And spaces allow us to do more than just analyze an area inside of an architect's model. If I come over and I just want to highlight this space here really quick, and what we're looking at right now is a zoning plan that's controlled with a color legend. We're going to get into the analytics of color legends in a moment. But I want to talk a little bit about spaces. If I just select this space and I look at my properties, I can look at all the different information that is or can be housed in a space. A lot of these spaces can be used to export in a GBXML file format to train, trace, or carrier HAPs, which is going to allow you to do your takeoffs a little bit faster inside of train, trace, or carrier HAPs or those other analytical programs that accept that GBXML format. But spaces can also be used to keep track of lots of different things inside of your Revit model. Any quantification can be tied to a space. Any sort of analytics can be tied to spaces, as well as the HVAC zoning that you're seeing here. Difference between a space and a zone is obviously this is the space that's there. And if I come here, if you guys see this zone as it highlights, if I click here now I'm actually looking at this zone, and you'll see a lot of the same zoning analytics inside of the zone. Just a real big help for HVAC engineers, anybody doing a heat loss, heat gain calc. You'll be able to drive a lot of information from here. Obviously, we're not going to get too far down the road of how we do these calculations. That's a completely different webinar. But here's a lot of your cooling, heating, and outdoor air information that's also included inside of those zones. Now, once we have our spaces placed, we can do a lot of great things with them. We can start to create a color legend view like you see here that's keeping track of our zoning information for us. But then that also allows us to do some things with schedules. And those schedules are very, very powerful inside of Revit. And so here I'm just going to come down to a common space schedule, and I'll look at that. And here's all the spaces that exist in this current project. Now, I'm looking at all the information from the room name and number to the area inside that room, the height from level to level, what's the volume of the room, the level it's associated to, offset information, all sorts of good stuff in here. But really the power of this schedule isn't so much the spaces, it's the fact that I can embed it inside of another schedule to help me keep track of what's placed where inside of a project. Now, one of the things that we've done here at CTC is develop this space airflow summary schedule that allows us to analyze a lot of that data. And so what we see here is a schedule that's not only keeping track of all the spaces, so here we see we have the entry room in the build, but also the number of that space, what diffusers are located in that space, the model number for those diffusers, the area for said space, and then when you export your GBXML data out to train, trace, or carrier HAPs and run loads, bring them back into Revit, it populates this calculated CFM rate. And so this would be the flow rate that you need to service this space, obviously coming from train, trace, or carrier HAPs. Now, what we've done with this schedule is we've also scheduled the flow rates that have been assigned to all these different diffusers. And then we've had a total set up for those diffusers right here. And we're going to compare this total across the calculated value and get our percentage of difference. So right now we can see that this is red, which indicates to me that I'm outside of my design range. You can see I'm 154% over, so 154% is 1200 CFM over 473 CFM here. But let's take a real quick look at what this space is inside of the model. So if I go back to my, well, I won't go to my working views. Let's go to my construction document views here. If I go to my construction document views, we're looking at this particular area right here. And now this is driven by spaces, so I just want to point out that as I come in here and select this space, we're looking at, here's our two linears, here's our two bars, and here's our return grill, because those are the only registers or grills inside of this space. And as you can see, let me escape there for a moment. Here's our flow rates that are applied. So if you remember from the schedule, here's 400, 400, 200, 200, and 0, because we did not have a flow rate applied to this return register. So This is something that happens automatically in Revit when you place your spaces correctly and your spaces go from the floor to the level above. It's very important that when we're ripping spaces that we pay attention to some of the settings inside the spaces. We want to make sure that we also rip the plenum space along with the occupied space. A good trick for that is to go into the architect's model, go into an overall 3D view, highlight everything, then use the filter tool to filter out everything but ceilings and uncheck the room bounding capabilities of those ceilings. Then save it, load it back into your MEP model, and now when you place spaces, it is no longer going to see the ceiling as a room bounding element. It will go past the ceiling to the next level. This is something that is commonly misunderstood inside of Revit, and is something that makes placing your spaces quite a bit easier and more accurate. So now that we've seen this inside of this project space, I want to go ahead and go back to that schedule, because I want to show you what some of the powers of placing spaces and doing your duct design properly inside of Revit can lead to. So if I go back to that space airflow summary and I start looking at some of these values, I know I have 473 that I need to go ahead and compute here. So I'm going to just go ahead and take all these down to 100, say for example. Take him down to 100, this linear bar can go down to 100 as well. Maybe this one is 130. And you watch the difference happen. Right over here, it's doing our calculations as we're making changes. And I'll take this one down to 132. So you see that I'm 3 under, okay? Not horrible, but within my design range, because obviously we round up by 5 CFM or down by 5 CFM depending upon the application. 460 to 473, so I could wring out a little bit here. I could maybe make these 135 instead. Now I'm a little bit closer, maybe 1% of difference there. That's an acceptable answer for the HVAC industry, unless we're doing some really close stuff. Anyways, so now I want to take this opportunity, now that we've adjusted these and we've seen that this schedule is looking at those values across all those diffusers and that space, let's go ahead and take a look back at that space where I had those tags placed. And you'll see that those tags have updated with the values I fed the schedule. It's because Revit, it really isn't a drafting tool as much as it is a database, and all the data inside of this database is reciprocal. It goes back and forth. And so we can make adjustments in the schedule and that will update the model and vice versa. So if we have that knowledge with Revit and we know that data is reciprocal, that means I can take something like this design space airflow summary schedule and use it to balance my entire job from the schedule, not having to go from view to view to view to go ahead and do any flow rate typing for each diffuser, because we know that that leads to some issues. You always forget one or you miss one or something happens. This way you're able to do it from the schedule, automatically compare that right away to your calculated CFM, and go ahead and basically complete your supply air data entry. But if we look farther to the right on this schedule, what you'll see is that we are not just looking at supply air, but we can also look at, because we've used a space and it understands the space analytics, we can go ahead and look at the return and or exhaust airflow across, and then measure our pressure drop as well. As many of you know, pressure drop is one of those things that has been requested more and more by building owners, especially if you're in any sort of healthcare or something like that. They're going to definitely want you to show this in a balancing report. So this becomes twofold. This becomes something that helps you with design and something you can hand right to the balancer so he knows what your intent was. So if we look at our return, we know that we have a return in that space. So here's our ceiling return transfer duct right here. And we're at 470 CFM right now. So maybe I'll go ahead and put this at 400 CFM. That in turn populates this return airflow column, and it says that we have a positive pressure of 70 CFM inside of that space that we are not returning. If we wanted to go ahead and type in 500 CFM here, we'll show that we're a negative pressure in that space of 30 CFM. So a very powerful schedule that we can use and is very useful across lots of different applications. But it was driven by the fact that we put our spaces in and we put our spaces in correctly. And so now if we go back to this layout here, construction documents in the model, we'll see that that information is updated all over, and of course is reading back to the schedule. A huge help, a huge improvement in efficiency when you use a schedule like that, simply because I'm not wasting my time going from view to view and having to click on each diffuser or do group selects of diffusers to go ahead and just type in flow rate information. Whenever we can automate a process or streamline a process in Revit, that's usually when we're becoming more efficient inside of Revit. So that was a little bit about spaces and how spaces can be tied to schedules and how powerful this all can be. Placing spaces is the first step in the setup of any MEP project. We're going to make sure that we place them and that we're using them properly and taking full advantage of what we can do with those. Now if we kind of turn our attention a little bit, as we got about 10 minutes left here, I want to be respectful of everybody's time, turn our attention a little bit to analytics and what we can do with proper setups. So if we go through everything that John talked about in the last part one of the series, we can go ahead and apply those things to some analytic views that we can create. We got some questions here on whether or not changing the CFM rate also changes the duct size. The CFM rate does not change the duct size. There is duct sizing capabilities inside of Revit here. You can take advantage of those duct sizing capabilities, which is kind of what we're going to be looking at with the analytics of the color legend. But you can go ahead and you can enter in some rules for, say, example, velocity or static pressure, however you'd like to size your ductwork, into the auto-sizing capabilities of Revit, and it will auto-size. It's one of those things that since I've been using Revit for a while, I tried that initially right away when I got Revit and wasn't happy with the result, albeit a lot because I didn't understand exactly how it worked. But it's just one of those things that I never really went back to just because I got in a lot of bad habits of just doing it myself. Having been here at CTC for a couple years now playing with that feature, it has gotten quite a bit more accurate and very useful. So I'm going to come up here and I'm going to go back to the energy analysis view that we started looking at right away. And the energy analysis view again is just the HVAC zoning. The HVAC zoning is controlled here by this color legend. And if I look at this color legend that's in place and I want to edit this scheme, you'll see that I can apply this color legend, or I can apply any color I'd like to this color legend. This color legend will look at zones, spaces, and rooms, so you can color your spaces differently. So you wanted to color them by, kilowatts or lighting or whatever you can think of. You can make several different types of color schemes. Then obviously you can make this color scheme be driven by name or filter, gross area, occupied volume. So all these parameters here are completely in play for any one of these color schemes. One of the things that kind of gets confusing about color schemes, however, is that you do have to go ahead and go into your Analyze tab and place a color fill legend, then come back, select that color fill legend before you can edit the color scheme. A lot of people kind of miss that step, and as you see, just by placing a color fill legend, it's automatically reading the same thing I already have input into this view. But I can come back, I can delete that, and we can just roll with this one we have. So this one just goes ahead and looks at spaces and zoning. That's all that color legend is really set up to look at. But I have some other ones set up here for flow and velocity. The flow ductwork that I have set up is just a simple flow, no flow scenario. So this is a view that's intended for you to be able to come into and just double check your design. Did I dot all my I's and cross all my T's? Obviously I see a lot of red here, and that presents a little bit of an issue for me. If I look at this color legend here, I just edit it, You can see that it's applied to the ducts category. Here's my flow, here's my velocity settings. Again, here's your title. You can apply it to any one of these different parameters that exist. And then once you've done that, you can write your rules. You can also edit the formatting if you'd like to. You can use your project settings or type in your own settings inside of here. This is what really allows you to kind of nail it down and set it for any specific special system criteria, be it high velocity or anything else. So I'm just going to go ahead and cancel out of this right now and just kind of show you the intent behind this color legend. So I see a lot of red here. That should raise some eyebrows and kind of grab my attention to say, hey, I didn't do my full job here. I need to go back and verify that I've added some information here. And so what I'll do here is I'm just going to do a group select right here. I'll use my filter tool to take out everything but the air terminals. Check none, add the air terminals back in there and click OK. Now that all the air terminals are selected, I can just simply come and apply a flow rate. So if all these were the same flow rate, this would work out great, but I'll just say these are all going to be 200 CFM and I'll hit enter. Now after I hit enter, that flow rate's been applied and you'll see the duct automatically update to show that there's a flow. Now as with piping and ductwork and anything else inside of Revit, in order for flow to work, it needs to see a destination and a source. Since we just finally gave it a destination for the CFM, that's when this color legend actually autofills. If things aren't connected or there is no CFM given to the source or the destination, the color legends will not populate. This is something that a lot of people struggle with initially when they start getting into some of these views and these analytical views specifically. But it's something that needs to be understood and that you need to understand with Revit if you're going to be successful with it. Now you'll see little jaunts like this here of red, and there's really not a whole lot that we can do about that, simply because if you look at this area here, you'll see that there's a little tiny green line that goes from takeoff to takeoff, and that's simply because Revit sees this as, all right, the CFM came to this point here in the center and then got dropped off here and dropped off here, and there's nothing continuing on to that end cap. And that's just something that you're going to have to kind of get used to with Revit. There's really no way that we can do that as Revit kind of calculates this way, and we're stuck with some of the capabilities of Revit as is. But also the other view that I had, or have to show you here, is this velocity view. And this ties a little bit into the sizing. As I said, I used the sizing tools initially when they came out and kind of got into bad habits after I didn't see that they worked the way I wanted them to. And so I kind of combated that with the good old ductilator and then creating some views like this so that I could go ahead and help myself in my design. But what we're looking here at is just our velocity, so our feet per minute across the ductwork. And now obviously this is looking at the CFM compared to the size of the duct. And if we go ahead and look at this color legend, I'll just hop into that scheme and I'll show you how we did this by velocity and then set up some rules for our feet per minute range. And what this is going to do is simply look at the size of duct again measured against the CFM. So if I look in areas like this where it's blue, I'm looking at, I got 600 to 1100 feet per minute. Maybe I can do a little value engineering on my ductwork, try and save myself a little bit of money, or the building owner rather, a little bit of money. So I can look at this and I can say that's a 14-inch duct. What happens if I change this to a 12? How is that going to affect my velocity? I can just go ahead and change that to a 12 and then see that it turns green here. Obviously green is good. It's right in the pocket of what I'm looking for, of 1100 to 1500 feet per minute. And so I could go ahead and accept that as an answer if that fits inside the criteria that I'm looking to accomplish. I could then go ahead and do this. Maybe 12 is good, maybe 10 will work too. So I'll come down to 10, I'll look at that. And it's a little high velocity going across there. That's not going to work out too well for me, I don't think. So I may want to go ahead and hit undo a couple times and go back to my green. But this, again, this color legend is set up specifically for these types of scenarios where you can very quickly and easily look at your design and try to make heads and tails of it. Does this all work as well as I would like it to? But again, obviously everything has to be connected. You have to have a source, a destination, everything connected, so every joint is connected, every tap or T is connected, and then everything also has a cap. We can't have open ends because obviously if air can blow out the end, Revit's going to have a hard time doing any of the calculations. As flow goes as well, it's also important to remember that fittings are data collection points, and ductwork and or pipe for that matter are transfer points. So the data would be actually coming backwards. So it comes from the diffuser, and it's travels down this piece of ductwork, is gathered by the takeoff, then travels down this piece of ductwork, gathered by this takeoff, travels again, and is gathered by this T-fitting here, and then again sent down. Now when it comes to things like static pressure reports, this is where Revit runs into a little bit of a challenge, simply because it's very difficult for Revit to understand the difference between, or I shouldn't say difference between, but how this air flows coming this way on a T versus going this way on a T, or vice versa coming this way, or how it flows down these three different options. And that's because there are three different options. If you look at something like a takeoff, this is simple for Revit to understand. The air is coming in here, it's going out here, or vice versa. It really can understand that information, and that is where it pulls from ash rate coefficients for static pressure. Now, if we have a T, for example, it doesn't necessarily pull from the ash rate coefficient tables. What it does is that static pressure information is housed in the connector for the T fittings. When it's housed in the connector for the T fittings, then we can give separate static pressure coefficients for each opening in the T, which would provide for a more accurate static pressure calc. Well, I can see I'm about a minute over here, guys. I'm going to go ahead and turn my attention to some of the questions here. Some people want to know how they can get the schedule that I showed out, the space airflow summary schedule. That is something that we've actually included in the mechanical productivity pack, along with lots of other goodies that really help you. A lot of what we've seen today, these color views, everything else, we've also included workflows just like this inside the mechanical productivity pack that we sell at CTC. So that is available to everybody. A question about space parameters being able to be loaded into families. As long as they originate from a shared parameter file, then yes. And then also some issues with the calculation point, the room calculation point with different pieces. We can take and change the room calculation point on any piece of equipment, like say for example a VAV box. The VAV box obviously is usually in the plenum space, and if you don't rip your spaces properly, so like the workflow I talked about where we go into the architect's model and we turn off their ceilings as room bounding elements, if you do not do that, when you place spaces inside of your model, it's going to stop at the ceiling. And then anything that would be in the plenum space wouldn't be automatically counted because it's not included in the space. However, everything comes with a room calculation point now, so what we'd be able to do is adjust that room calculation point to be lower, say significantly lower, 5-6 feet below that VAV unit. Therefore, it would be counted in the space, and we could use that would show up in our space schedules, quantification schedules, and everything else. So, are there any more questions there, guys? Anybody else? Alrighty, I'll see you guys signing out, dropping like flies here. So with that, we'll go back to the PowerPoint here, and thanks everybody for attending. If you got any questions, feel free to reach out to us at CAD Technology Center. Obviously, if you need any support or any technical help, we're always here. That email address is support@cadtechnologycenter.com, or you can call us at 866-941-1181. This webinar is also going to be posted on our YouTube page here shortly, so feel free to let your friends know or pass around the office so everybody can get a little education on ducting inside of Revit MEP. Once again, guys, thanks a lot, and we'll see you next time.